Okay, so let's continue to gain some experience with exponents. The skills required to be able to understand the concept in this video is to be able to recognize when to subtract exponents and when to add them. Here's some sample problems that you might want to try to see if you're ready to continue. All right, let's check this now. So the first one here on the left, I see, and hopefully for all of these, you recognize the same base. So that has to be established. We're looking for same base, like 9 and 9, same base of 4 and 4, same base of 6 and 6, 10 and 10. Having checked that, let's look at the exponents. What operation do we associate when dividing same base? So hopefully you see division, and I associate that with subtraction. Therefore, I'm going to write this as 7 to the 8 minus 3. That's the exponent. And that becomes 7 to the 5th. 7 to the 5th power, all right? If you did it in your head, that's fine. The main idea is recognizing that. All right, next one is same base multiplication. We multiply the same base, we're going to add the exponents. So therefore, I'm going to write this one as 9 to the 3 plus 8, or 9 to the 8 plus 3. Notice that for multiplication, the order doesn't matter, but for this division one, 3 minus 8 is not the same as 8 minus 3. This 3 minus 8 would have given us a negative 5, so be very careful with that. So we know this expression is 9 to the 11th. All right, cool. Next one down here is, again, multiplication of the same base. Should be 6 to the 13 plus 7. That's the same as 6 to the 20th power. Okay, let's pick up the pace. Right here we have 4 to the, and the order that we should write it is, or think about, is 12 minus 5. Therefore, this should be the same as 4 to the 7th power. All right, 12 minus 5 is 7. If you did it in your head that way. All right, cool. So let's do these on the right side. This one's, don't worry about what 3 to the 0 means right now if you don't know that, but let's apply the idea. This still means 3 to the 0 minus 4 in that order. It can't be 4 minus 0. That's incorrect. So this just becomes 3 to the negative 4. And if you don't know how to deal with negative exponents, don't worry about it. That's not the emphasis of this video right now. There will be a video about that, or the next one's coming up probably. All right, so next one is same base. Multiplying means we can add the exponent and write it as 10 to the 3 plus 5, which is 10 to the 8th power. All right, and then so I don't have to write the exponents here, 3 plus 5 plus 4. Let's just do it in our head. All right, or you check yourself. So because it's multiplying by 10, even though it's 3 times, it's still the same base. All we need to do is add the exponents. If you don't believe, go ahead and expand all of them and verify that we have, indeed, it's going to be 8 and 4 is 12. Indeed, 12 tens. All right. Because look, this part right here was the same as that part. That already had 8 of them, plus 4 more should make 12. And that should also make sense. All right, next one is, again, same idea. Even though we're multiplying 4 times, it is the same base. Therefore, we can apply that idea. Verify if you don't believe. And then this becomes 3 4 times, right? And there's 4 3s, or in whatever order or however you want to do it. It's still 5 to the 12th. That's the main idea for this. Okay, great. If you're comfortable with that, then we're ready to proceed and see a new pattern, new idea going on here. We talked about when adding the exponents, when we subtracted them, and that's about all we've done so far. So let's continue and find out. The way we're going to do that is by first rewriting this expression in expanded form, and that's hopefully it's going to allow us to simplify. Because if you don't know a rule, even if you don't know the rule, I wonder if you know why that rule works. So let's find out, okay? We have a to the 3rd to the 4th power, but it's what's being raised to the power of 4? The a to the 3rd. So I like to think of it as whatever's inside the parentheses, think of it as something to the 4th power. This one right here, instead of 7 to the 4th to the 3rd, let's think about it as something to the 3rd power. You see that? Something to the 3rd power. That makes it easier to comprehend. Therefore, this one is something to the 6th power, and this one is something squared, something squared. All right, let's think about how we expand this. How do we expand something to the 4th? What does something to the 4th power mean? Well, it means something times that something times that something times that something. And what's the something? It's a to the third times a to the third times a to the third times a to the third. And that means we're multiplying the same base 4 times. So therefore this can become, we know that this becomes a to the what power? A to the 12th. And hopefully you can see how that was the same. Let me write an equation down here. Let's redo that. Oh man, that doesn't look very good. Okay, let's fix it. There it is. We have this equation right here, and I want you to think, is there a way that we can go from here to here very quick? All right, think about that. As we think about the next problem, keep that in mind. So again, we think of the next one as something to the third power. All right, something to the third power. So what does that mean? It means that we have something times that something times that something. And what was the something inside? It was 7 to the fourth times 7 to the fourth times 7 to the fourth. And notice how that one becomes 7 to the, adding the exponents 3 times give us an exponent of 12. Oh, I don't know if I like the exponent is 12 again. But all that means is that 7 to the fourth to the third is the same as 7 to the 12th. Just like a to the third to the fourth meant a to the 12th. And maybe we can see something different here. But let's see, let's expand this one. And we have something to the 6th power. And that means that we have something times something times something times something times itself 6 times. I think that's 6. 1, 2, 3, 4, 5, 6. All right. And what's the something inside is going to be 9 to the 4th times 9 to the 4th times 9 to the 4th times itself. There we go. That many times. And what that means is the base is still 9. So all we need to do is just add the exponents. We're adding the 4 6 times. Do you know? I'm sorry. Yeah. We're adding the 4 6 times. Do you know how to quickly do that? Is by multiplying. If you really are thinking of that, that would be 24. And we know that 9 to the 4th to the 6th. And the idea is, again, do you see a 24 on this side? Do you see an exponent of 12 on the left side? Exponent of 12. And let's just see the one last one. It means that something times something. Because we have something squared. What's the something? It's 5 to the 12. Times 5 to the 12. Oh, I just realized I'm not very good at picking my exponents in this video. Okay, that's fine. The concept's still the same. So this means that this is 5 to the 24th. And do you see a way that we could have quickly found that exponent of 24 here on the left side? How could we quickly have found that exponent of 24 here on the left side? And this 12, how could we quickly find it? Just as here, hopefully you were thinking this is the same as a to the 3 times 4 is equal to a to the 12. That's really what's happening with the exponents. Do you see that we can multiply the exponents to get that 12? If we multiply these exponents, would that become a 12? Let's find out. This is 7 to the 4 times 3. And 4 times 3 is the exponent. Equals 7 to the 12th. It makes sense. This one right here can be written as 9 to the 4 times 6. Or 6 times 4. The order doesn't matter for multiplication. Therefore, this is 9 to the 24th. See that? This is 5 to the 2 times 12. I rewrote it in different order, so you see that order doesn't matter. And then this is 5 to the 24. I want you to see that order doesn't matter because we can rewrite this as 5 to the 2nd to the 12th power. Wouldn't that still give us a product of 24? All right, so keep that in mind. I'm not going to write them for all of them, but that idea is true. All right, so let's see if we can apply that faster. Rather than expanding them, look, if we get to the 7th power, and even the 1 to the 6th, that was not fun expanding that one. We're not going to expand them all the time. Hopefully you recognize when are, for what case or what scenario did we multiply the exponents? When can we multiply the exponents? And it was the case when we get an exponent raised to another exponent. Or think of it a power to another power. Power to power or exponent to exponent. Okay, do we have that in these down here? And hopefully you recognize by design, all of these were designed power to a power or exponent to exponent. All right, so let's, because we recognize that, let's go way faster. And we can say that this one is 12 to the 5 times 6. And if you wrote 12 to the 30, that's fine. And an alternate one could be, oh, this can be written as, oh, it doesn't ask to rewrite. So we'll skip that part. All right, faster. This one would be 12 to the 9 times 4. I'm sorry, 8 to the 9 times 4, which is 36, right? This one would be k to the 8 times 7, which is 56. And this one would be 2 to the 5 times x. We don't know the value of x, so I'm just going to write it as 5 times x. All right, if you simplify this to k to the 56, that's all right. But that's why I wrote it like this, so that sometimes we're not able to simplify it and we can think the same way as before. All right, then therefore this one becomes what? 6 to the 18 times 1/2. Now that one looks a little bit weird, so I am going to simplify it as, let's write it down here actually. 6 to the 9th, right? 18 times 1/2 is 6 to the 9th. Yeah, that one just looks a little better that way. And this one will become 7 to the 1/2 times k. That's all the exponent, all right? 7 to the 1/2 times k can be simplified to 7 to the k over 2. But all right, if you multiply these two, that becomes k over 2. And therefore this can be represented, this next one, as 5 to the x times 4 or 4 times x. I'll rewrite it as 4 times x. Looks better that way. And this one right here, the last one, 4 to the n times 1/4. And again, that can simplify to 4 to the, that's a weird looking arrow, 4 to the n over 4. Would probably be the simplest form of rewriting that one. And there it is, okay? There's that application of exponents that will make our life easier. What do you need to recognize in order to multiply the exponent? It's exponent to another exponent, power to power. All right, cool. And then let's see from that, we can do the opposites. Sometimes we're going to be able to go the other way around. If we start with this, but can we rewrite the other one? For example, that means, all right, we can rewrite this as, oh, this one's a cool application. You'll see why. This one means 9 to the 5th power. When do we, as like the question we should be thinking about, when do we multiply exponents is when we have an exponent to another exponent. But here's what I want to point out. Is this the only way of writing this? Because for multiplication, it doesn't matter. 5 times 4 is going to be the same as 4 times 5, isn't it? You can verify that for yourself. Is this product 20? And is this product still 20? So there's 2 ways we can rewrite this one, which is kind of cool. I like that. This can imply two different expressions, all right? So keep that in mind. Not just think of that one, we think of the other one. So therefore, in what 2 ways can we, or what are the alternate forms of this one? It's the first one that you should notice is 6 to the 7th to the 3rd. But hopefully you also thought 6 to the 3rd to the 7th. All right, it's a pretty cool way of thinking about those two. Therefore, using the same kind of logic, this one becomes 8 to the 5th to the x, or it can be written as 8 to the x to the 5th. Nice. Hopefully you're getting experience and comfortability with these. Pretty basic ideas in my opinion still. All right, next one could be written as 3 to the 1/2. If you don't know what 3 to the 1/2 means right now, don't worry about it, to the k. Or it could also be written as 3 to the k to the 1/2. And yeah, if you want to write it as k over 2, that's fine as well, but that was not the point of this one. Because here I want you to recognize, all right, this is p over 4, but therefore we don't have a pattern for dividing exponents. We've only multiplied them, added them, and subtracted them up to this point. So we need to think, how can we rewrite this as a product? And hopefully you saw the last example was kind of hinting at it. Write it as 1 over 4 times p. So we can write this as now a to the 1/4 to the p, or a to the p to the 1/4. Those are both equivalent. And what I was thinking earlier is that even though this is pretty basic still, it's kind of cool, right? And yeah, I don't really know a lot of mathematicians that go as far as rewriting those two in detail. All right, this one is, now if we start with this format, then we can say, all right, I know that this also means 12 to the 1/3 to the 5th power, right? We just practice that. But it could also mean 12 to the 5 times 1/3, which is the same as 12 to the 5/3. That's pretty cool. So there it is. This is the main idea for multiplying exponents. If you're having a little bit of, I don't think trouble, if you just need more time, I think that's normal. If you just need more time, rewatch some of the parts that gave you trouble, or not trouble, but that need more rewatching or more practice. Watch those because this is the end up to the new concepts. The next part, letter B, is just to ensure that we give some practice to our adding and subtracting exponents. All right. So if you want to practice your adding and subtracting exponents, then stick around. Otherwise, have a good day. And it's just 6 problems. So if you want to pause it and try it for yourself, this is the time, because we're going to check now. All right. The way we should think about it is, all right, what's happening to the exponents? We're subtracting the exponents. And then we think, for what operation do we associate subtraction with? Is it addition or I'm sorry, is it multiplication or division? It's got to be division. So hopefully you're thinking some form of 12, not some form, it's got to be 12 over 8. I mean, 12 to the 8th power over 12 to the 5th power. It's got to be in that format. All right. So I don't mean like, oh, 12, just 12 to the 3rd. I don't mean just do this, you know, like, no, that's not what we're doing right now. This is what we're doing down here, this. All right, when we see adding exponents, hopefully you associate adding with multiplication. This is 6 to the 5th power times 6 to the x. That's what I mean by rewriting it. With the same kind of thinking here, this one is now subtracting exponents. So therefore, this is 4 to the k divided by 4 to the 6. And adding exponents means we're multiplying the same base. 5 to the w times 5 to the 8th. Be careful with this one. What is the base? The base is 5 over 4. And we're adding the exponents. So therefore, it is 5 over 4 to what power? To the t power. That's the letter t. Times 5 over 4. Notice the use of parentheses both times on purpose. To the 7th. All right. So otherwise, it can mean only the 5 is being raised to the power. All right. This one's got a little bit more. And it's got all 3 of them combined, all the 3 ideas we learned so far. So if you got this one, then you understand everything up to this point. First, you should notice subtraction. But what I mean is there's also multiplication, if you didn't notice that. So this is going to become 4 to the 7th divided by 4 to the 2x. If you got that far, that's okay. But it could also be 4 to the 7th over 4 squared to the x, or with the denominator of 4 to the x squared, right? Either one of those 3. If you got either one of those 3, that's great. If you got 2 of them, that's excellent. If you got all 3, then you're definitely ahead of the game by now. If you're a little confused, like I said, don't worry. We're going to revisit all of these ideas. You're going to get a lot better at it and more comfortable, but it doesn't hurt to go and rewatch the whole video or parts of this video if you feel like you haven't quite mastered this yet. If you feel like you understand it for the most part, I think you could move on and be okay in the next few videos. All right, so have a great rest of your day, and I hope you hear me talk more math in the next few.